few years ago, a colleague of mine did a video for Numberphile where she looked at choosing a toilet at a music festival. And unusually for Numberphile, what they did was they took the mathematics out and they put it in a separate video. And I'll put the links down below. You can have a look later for yourselves. And I guess the reason they did that is because they thought that most viewers would not be terribly interested in the mathematics. Now, if that's you, if you aren't naturally attracted to working in equations and formula, and maybe you're not comfortable with algebra, or maybe you're just a bit lazy, like myself, you might not want to work through the mathematics. What we're going to do today is we're going to look at an alternative way of getting to the same solution. And what we're going to do is we're going to think about how a human being would solve this problem with no calculator, no computer, maybe a pen and a paper, but no algebra, nothing like that. And we're going to turn what that human being would do into a paragraph of English text, and that's going to be our solution. And if you're thinking ahead for how this is going to go, it's actually our algorithm. We're going to take our English paragraph and we're going to use that as an algorithm, and we're going to program that in an agent modeling environment. And along the way, we're going to see NetLogo lists, which are horrible, and we're going to see NetLogo's behavior space, which is amazing. Let's get started. Now, the rules are that we have a row of toilets and we sample from the row of toilets. And we sample from the row of toilets to get a measure of the state that they're in. We get a measure of what the good ones look like and what the bad ones look like. And then once we finish sampling, we go through the rest of the toilets one at a time and we choose the toilet that is better than the sample that we've looked at. You're not allowed to go back, you can only go forward, and that's the rules. Now, if our sample is too small, we won't get a measure of the state of the toilets, and if the sample was, for instance, a really bad one, the next one we choose might be a little bit better than that, but not great, and we would be stuck with that one. So if the sample is too small, it can go wrong. On the other hand, if the sample is too big, there won't be a lot left over at the end from which to choose. So there's going to be some sort of optimal sample size in the middle, and that's what we're looking for. And Numberphile calculated this to be 37%. It's actually quite a well-known result. So their answer of 37% is right, and that's what we are hopefully going to try and find today. And to do it, we're going to use NetLogo. So here we are in NetLogo. So all I've done so far is I've changed the size and shape of my environment up here in the settings. And you can pause the video and look at these if you want to recreate them later. You make sure that these two are not ticked for reasons we'll talk about later. This is 0 because NetLogo always starts counting at 0. So when it says 0 there, what it really means to everybody else is 1. I don't agree with that, but that's the way they do it. And so that's the environment going up, and the environment going across. It goes across. I want 10 squares at the minute, so that's from 0 to 9. That's why that's 9. And if I click my setup button, you can see each of the toilets that I have. And all I'm going to do is I'm going to assign a quality to each of these squares. In NetLogo they're called patches, and that's what the list is for. And then I'm going to set up a little computerized version of myself, a little computerized guy, and the little guy is going to go and check all of these toilets. So if you were doing this as a human being with no calculator, what would you do? Well, what you could do is you could try it. So you could find a row of toilets and go to the first one and have a look, and the first time you do it, use a sample of 1 and make a note of whether or not you found the best toilet or not, using the strategy that I mentioned a minute ago with just a sample of 1. Then try it with a sample of 2. Did you find the best toilet? try it with a sample of 3, try it with a sample of 4, etc. And if you approached the toilets in a random order, you could do that more than once. So you could do a sample of 2 100 times, a sample of 3 100 times, a sample of 4 100 times, and that would take forever. But when we program our little computer guy, it's not going to take forever. He's going to be able to do it. It won't take him long. It certainly won't be instant, but it won't take him long. Let's go to the code and see what we've got so far. At the minute, I've got my clear all, and I've assigned patches to be a color. And this next bit is the bit where I use a list. And the list generates a random set of numbers from 1 to 10, because I've got 10 toilets. And those numbers, it generates the numbers 1 to 10 in a random order. And those are going to be the quality, those are going to capture the quality of each toilet. And I'm going to assign one number from that list to each toilet. Now the way I did that is just went on Stack Exchange and copy pasted some code to go through a list and take an item out one at a time without replacement. Now I'm going to post the code either, well, I'll put a link down below, or I'll post the code down below if YouTube lets me, and you can have a look at it later. But that's all that bit does. So if we run that, each of our toilets will now have a quality from 1 to 9. And then the last thing I did was I created our computer guy, and there he is at the first toilet, ready to assess the first one for us. Of course, I should have said that the numbers go from 0 to 9, not from 1 to 9. So you can see there we've got a toilet with 0 quality. And what I have done is I've brought up the remainder of the code here, and you can see there's not much to it. And what we're going to do is we're going to have the code run in 3 parts, essentially. We're going to ask the turtle, first of all, to sample the toilets. And the number of toilets that they're going to sample is a variable. And I've got a slider here with a number of tries. So with try set to be 3, the computer guy will sample the first 3, get the best quality that he finds there, and then go along the remainder, and he will stop when he gets to one that's better than the best quality. So the best quality here is 4, and as soon as he gets to this toilet it's 9, so he's going to stop there. Now, there will be computer programmers who might object to this, that they would say that this is an inefficient way of doing it. We should split our toilets into 2 groups, sample and non-sample, and use a function like max to find the best toilet in the sample. Now, in this simple example, it doesn't really matter, but I would actually argue that that's not the right thing to do, because it's not how we described the behavior of a human who would do this in our little English paragraph that we said would be our algorithm. So it might not matter here, but it will matter in more complicated models if we are actually trying to model human behavior. We should keep our code to be as close to the human behavior as possible. Anyway, p-label here is a variable that holds the number which we are using to represent the quality of the toilets. And then this bit does the sample. So repeat try minus 1 times. So try is 3. We want to assess the first 3 toilets, but the first one is toilet 0, which is why we've got that minus 1. And each time we go forward 1 toilet, and if the p-label that we find is better than our current best, which is a variable that we hold, then change our current best to be the p-label that we find. And then the second bit is to repeat the remainder times. So we've got 10 toilets, 10 minus try times. We go forward 1. Incidentally, you could do 9 minus try, because there's no real point to assess the last toilet. But let's not worry about that. It's not going to be hugely inefficient to just include that one. But having said that, we do have to get onto the final toilet just in case we don't find one that's better than our sample. So actually we do need to do this 10 minus try times. here, if the p-label that we find, so if the quality of the toilet that we find is better than our current best, then set the choice to be the p-label that we are sitting on. Choice being the toilet that we are going to choose to use. And we can stop. We don't have to continue. And we can just, at that point, go for a wee-wee. And if we find that we get to the very end, so if we get to the edge, so if the patch ahead is empty, is null, is nobody, which if you remember way back at the start, we made sure that we unchecked these boxes. That is why, so that the patch ahead would be nobody. If we get to it, then we're stuck with the last one. We have to set our choice to be the p-label of the last one. Here we go. Let's try it. And we find the 9. So the computer went through these first three, found the 9, job done. Let's try it again a wee bit slower. I think it's going to find the 9 again. No, oh sorry, no, I didn't see the 7 there. This time it gets all the way to the end and it's stuck with the last one that it finds. Our algorithm is done. So let's have a look at how we're going to figure out what the optimum number of tries is. If we go to Tools and Behavior Space, I have set up an experiment. Let's have a look at this. Behavior Space will run through all possible values for try from 1 to 9. Okay, so we've stopped at 9. And it will output the value of try that it's testing and the final choice of the turtles, of our one turtle. And it will do that 1,000 times for each value of try. So it's going to try one toilet 1,000 times, then two toilets 1,000 times, then three toilets 1,000 times, etc., etc. And each time it's going to just essentially click the setup button and then click go, just exactly as I did. So let's try it. If I click on run and then OK that, save the file, and it will take a few minutes to run. Actually, I think it'll take about a minute to run. So I'm not going to show you that, and I'll show you the results in a moment. And here they are. So this is what Behavior Space has outputted. And what we're going to do is we're going to count the number of times that the turtle found the best choice when they tried one toilet, when they tried two toilets, when they tried three toilets, etc. And to do that, we are going to use a pivot table. So let's delete that to get these up to here. Let's do an auto filter, and then we want to just see the best ones, which is 9. Now, for some reason, I can't pivot that as it is, because it will include all of the data, not just the ones that are appearing on the screen. So what I'll do is I'll copy paste it into a new spreadsheet. Someone can tell me if there's a better way of doing this. So we need a new spreadsheet. We want to paste in those and then do a pivot table. So insert pivot table with the current selection. We don't want that. We want to have the number of tries down the left hand side, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we want to count the number of times 9 appears. So we want to do a count. Okay, did it work? And it did. Okay, so we only did it with 10 toilets, so we're not going to find 37, but I will repeat that whole thing now with 100 toilets and show you those results. Okay, I didn't analyse the results of all 100 tries, I only selected a few, but I did crank up the number of repetitions to 4,000, and at 4,000 you can see that 37 is coming out as a clear winner. So that's the best number for our sample. So if you want to find a clean toilet, sample 37% and then choose the next best one. Bye-bye.